Hello everyone, in this video we are going to learn how to create and analyze an intersection in Vistro software. The intersection we are going through is the intersection of Columbus Avenue and Center Street in Roxbury, MA. As you can see in the map, the Columbus Avenue is a north-south street. On the left we have Center Street and Ritchie Street on the right. If you install the software and open it, you may not see the background map on the left side of the screen. For that, we are going to go to Map Layers and set it to OpenStreetMap. Now the map appears on the screen. Before going through, I'm going to change some settings. I click on Edit, open the Global Settings window. I set the default lane width 10 feet. Uncheck the located in CBD. Set minimum green to 6 seconds. And walk interval for pedestrians 7 seconds. Now that we all set, I'm going to find the intersection on the map. For doing that, I use rolling the middle mouse button to zoom in and zoom out. And for moving the map, I press and hold the middle mouse button. When the hand appears, I can move the map. Here is my intersection. After finding the intersection on the map, if you look at on the left, we have some menus. The first one is signalized intersection. I click on it and click on the location that I want my intersection to be. You can see the intersection appears. For having all legs on the right direction, I click on end of each lane and move it to the correct place. Now that we placed our intersection, if you look at on the right, we have a table of data. On the top, we have some tabs that we go through them and we enter the data for our intersection. First one is intersection setup, second volumes, and traffic control is the last one. In intersection setup, we enter the geometry of intersection. First is the number of intersection. We have one intersection now. We can put a name for intersection. We can name for each street. Next step is determining the lane configuration. Lane configuration indicates the number and type of lanes on each approach. If I click on the three-headed arrow, we can see a little window will appear. In this software, we have two ways to determine the lane configuration. The first one is using the predefined lane configuration in the software. If we have them in the reality, we can use them. For example, for Columbus Avenue northbound, we have one exclusive left lane, one through lane, and one shared lane between through and right turn. Here we have it. And the second way is to use the option on the top. If you notice my mouse pointer, there is a red or minus section and green or plus section on each arrow, and I can add or delete the lane configuration. I click on OK. For northbound, I have one exclusive left lane, two through traffic, and one exclusive right turn, so I use the predefined. But for Center Street, if you look at the map, we have one exclusive right turn, one shared lane between through and left turn, and one exclusive left turn. We don't have it in built up lane configuration in the software, so I can build it by myself. I have one exclusive right turn, one shared lane between left turn and through traffic, and one exclusive left turn. Click on OK. For Ritchie Street, we have only one lane that all traffic goes through. Next thing is lane width. I'm going to let it to be 10 feet for all lanes. After lane width, we have to determine the inter-pocket lane settings. If you look at on the map, we have a exclusive left turn and it's a pocket lane. So the number is 1 and the length is 145 that I measured from map. For Columbus South, again, we have one pocket lane for left turn. The length is 145. But if you look at the map, uh, we have an exclusive right turn, but it's not a pocket lane. It's just a continuation of a lane. So I put it 0 and it will be continued to the end of link. In Center Street, again, we don't have a pocket lane for left turn, but we have a pocket lane for right turn that its length is 245. And for Ritchie Street, we don't have any pocket lane. The last thing in this tab is settings for crosswalk. Here we have a crosswalk and you see all of them are checked. We have crosswalk on the map. If I uncheck it, it will disappear. And if I check it again, you can see we have crosswalk width that all of them are 8 feet. I'm going to let it to be, and the software automatically calculate the crosswalk length. But it only sum the lane width and it's not accurate. So I'm going to measure them from the map and enter them. The measures you see in the map is the actual length of crosswalk. I'm going to enter the measures minus 10 feet because Vistro assumes that pedestrian clearance, which is equates with flashing don't walk, is not allowed to overlap with yellow time. So because yellow time is 3 seconds long, we want flashing don't walk to be 3 seconds shorter than what Vistro thinks is needed. And our trick for accomplishing that is to make the crosswalk 10 feet shorter. So I enter the numbers 10 feet less than what is in the reality. Here we are all set in the intersection tab and we go to the volume tab. In the volume tab on top, we have a summary of lane configuration. We are going to enter 5 data sets we have and they are given to us. We enter to the software. First thing is the base volume I entered. The next thing is the percentage of heavy vehicles. I enter what we are given. Third thing is right turn on red. The right turn on red is allowed in all direction except for Columbus northbound. So uncheck the right turn on red for Columbus northbound. After right turn on red, we are going to enter peak hour factors. After entering the peak hour factor, I want to show you a total 15 minutes volume and total analysis volume that are calculated by software from peak hour factor and base volume we enter. Software first calculate the total 15 minutes volume and then total analysis volume that is going to be used for analyzing our intersection. So this number is going to be different than the base volume we entered at first. The last thing here is the pedestrian volumes. Pedestrian volumes in this software are tied to a corner, and corners are in turn tied to an approach. An approach's corner is the corner on the right side of the approach. Here, outbound means leaving the corner, and inbound means arriving at the corner. By default, major street is north-south and minor street is east-west. So in this project, we don't need to change it and we already are set. So I start to enter the volumes. If you notice that when I enter the volume for each of the minor or major streets, it will go for the other one because leaving for one is entering for the other. Now that we entered our 5 dataset in the volume tab, we are going to go to traffic control. Here on top, we have a summary of lane configuration, names, and traffic we entered. Just controlling things in the intersection settings. Make sure the analyze intersection is checked. The period of analysis is 15 minutes. Located in CBD should be unchecked. And make the cycle length 100 seconds as we are given. Actuation type is fixed time. In the same table, we have phasing and timing. At the first row, we have control type, which means what kind of behavior we want our turning to do. If you look at the existing timing plan, uh, it is pre-timed. The symbol means phase, and solid arrows indicate a protected movement, and dashed arrows indicate a permitted movement. If I start from Columbus northbound, we have protected and permitted for left turn. If you look at the diagram, we have left turn on phase 1 and also it is running on phase 6. So it is protected permitted. I open the menu and select the protected permitted. Both true and right turn are permissive. Left turn for southbound in Columbus also are protected permitted. It is running in phase 5 and also in phase 2. If you notice the right turn southbound in Columbus Avenue, it is running in phase 2 and also is running in phase 3. When a movement is running in 2 different phases, which is separated by barrier, we call it overlap. So I open it and select the overlap. Normally in the dual ring diagram, we have parallel movements in the same direction in intersection. For example, for east-west and north-south, they run in parallel. But if you look at this diagram, in east-west direction, the eastbound and westbound run separately and in series. We call it split. I open the menu and click on split. You see all of them is changed to split. But if you notice, the right turn for Center Street or eastbound right is running in phase 1 and phase 3. It is the same as right turn for southbound Columbus, and I have to select on overlap. After setting the control type, I am ready to use the default signalization of the software. So I go to the type. We have a button look like a black and white signal head named create default signalization. I click on it. Software asks me which setting I'm going to choose for left turns, leading or lagging. I let it to be on leading. Click on OK. We see the software change the cycle length to 240. So I change it to 100 seconds again. This time we have another button which name is optimize split. I click on it, but it gives me an error. It says it cannot run less than 110 seconds. The reason is that crosswalks on Columbus Avenue are very long and the clearance time doesn't fit in 100 seconds for all direction for pedestrians. For solving this and seeing the result of the existing timing for cars, I use a trick. I make the pedestrian walking speed higher for making pedestrian clearance shorter and still have 100 seconds. I use 15 feet per second, which is a ridiculously high speed for pedestrians, and I do it just for shorten the pedestrian clearance time. I have to create default signalization again. Now we can see that the pedestrian timing are not constraining. Now that we have 100-second cycle time, we go to the top. We have an option named optimized split. I click on it. It asks me for objective function. I choose B over C balancing. Click on OK, and we can see there is no much change. As you notice in the given diagram and the software diagram, if we compare them, we have signal group 8 here and phase 3 on the given diagram. They are the same. They are both for eastbound stream. And the other thing that is different is the order of phases. We have signal group 4 first and signal group 8. If we want to make it like our diagram, we go to the sequence and change them. Now we have the order of our phases looks like our diagram. The last thing I'm going to check here is the overlap in my phases. If we go to the software diagram, in front of signal group 1, we have OV. OV means overlap. It means it has overlap with some signal group, and if we look at in front of auxiliary signal groups, we will see 1 and 8 have overlaps. It means that the right turn on Center Street has overlap with signal group 1. But for right turn on Columbus Avenue southbound, we will see the software didn't do it correctly, and we can do it manually by click on 2. A menu will open. I will check number 8 and click on OK. The next step is to create the existing timing. If you compare the split's timing in the given diagram and the software diagram, you may understand they are not the same. For changing the diagram in the software, I click at the end of each split and hold it and move it. Now I have exactly the same timing as I have in the current signal timing diagram. So I'm going to check some settings to make sure that everything is right. First thing is we have to check our amber or yellow time and all red in the timing. We can see all amber or yellow are 3 and all reds are 1 seconds. So as we have in our diagram. And by that, I'm going to explain to you what does the number in the phasing in software means. For example, here 28 seconds is the sum of green, yellow, and all red. It is not 28 seconds for green. It has 3 seconds for amber or yellow, 1 second for all red, so it has 24-second green in this split. Next thing I'm going to check is total loss time per cycle. As you can see, all of the phase have 4 seconds for their total loss time as we assume in our calculation. The final thing is to check V over C ratio to see if the timing works well or not. If you notice, all of them are less than 1 except for one movement. This is the southbound true, and if we look at the volume, it has 1261 vehicle per 2 lanes, and V over ratio is over 1. It means that it doesn't have enough capacity to serve the volume it has. It only has 29 seconds, and it means that 29% of the cycle is for this. Now that we learn how to analyze the existing situation, I'm going to change the pedestrian walking speed to 3.5 feet per second, which is the actual speed. This time I am going to use the second button on the top, which name is optimize speed and cycle time. I click on it, it asks me the objective function, leave it to be V over C balancing, cycle optimization setting between boundaries, and it has a lower and upper bound for the cycle length. I click on OK. Again, we see we have a 240-second cycle time, which is not an efficient cycle time. I leave it up to you to find a better and shorter cycle. The last thing is to make a report out of our project. For doing that, I go to the File menu, click on Print Report. When a Print Report window opens, at first it asks me a name and place for a report file to save. I put a name for it and click on Save. The important part in creating a report is to find the best report we want from the software. For that, I go to the second tab, which name is Select Reports. Here, software provides us several kind of reports. I don't want all of them to be in my report, so I uncheck all of them. The only ones I want, the intersection analysis summary and intersection level of service. The intersection analysis summary gives me a short and summary of my intersection, and intersection level of service report gives me a detailed report of my intersection. I check both of them and click on print. Software save me a PDF file, which is the report of my project. In this tutorial, we learned how to create the geometry of intersection, enter the data, and analyze our signalized intersection.